Welcome back for another deep dive. This time, we're tackling a big one: AI, self-evolution, and long-term memory. Like, how can AI learn and adapt like us humans, especially when it comes to remembering stuff long-term? It's like, we want AI to remember our birthdays, not just spit out facts, right?
Yeah, exactly. It's a huge challenge in the field right now.
Yeah.
You see AI, particularly these large language models, they're amazing at crunching massive amounts of data, but they often struggle with actually holding on to personalized information and then, applying that in new situations. It's almost like they lack that personal touch,
Yeah.
that thing that makes us humans unique.
So how do we bridge that gap? How do we get AI to think less like a walking encyclopedia and more like a friend who remembers your inside jokes? Well, the research we're diving into today suggests that long-term memory, or LTM for short, might be the key to making AI less robotic and more human.
I think that's a great way to put it. Think of it like this. Newton's law of gravitation, right? It basically takes tons and tons of data about how objects interact and boils it down to this super elegant formula. AI models, especially LLMs, they do something similar, compressing information. But here's the thing. What they're missing is that ability to actually build upon that knowledge through experience like we humans do. And that's where LTM comes in. It's like the bridge between simply processing information and actually learning and evolving from it.
Okay, I'm starting to get the picture here. So LTM is kind of like giving AI a personal scrapbook, right? A place where it can store memories and experiences. But, and correct me if I'm wrong, doesn't the paper argue that our current AI models have some pretty serious memory limitations? I mean, they can't exactly reminisce about childhood vacations like we can, right?
That's exactly right. The vast majority of AI models today, they rely on what we call a context window, which is essentially a short-term memory buffer. It's kind of like someone who can only remember, say, the last few minutes of a conversation. And then you have parametric compressed memory. This is where the AI stores knowledge and its parameters during training. It's like teaching the AI specific skills, but it's static. It's not easily updated and changed.
So how do we help AI graduate from short-term memory to a more dynamic LTM? I mean, we can't exactly transplant a human brain into a computer, right?
No brain transplants needed, thankfully. The research, it actually suggests we take a page from ourselves. They dove deep into the mechanics of human memory, how we encode, store, and retrieve information. Our brains, they're incredibly good at prioritizing, forgetting irrelevant stuff, and then using contextual cues to recall things. These principles, they could be super valuable for developing LTM and AI.
So it's like we're reverse engineering the human brain to unlock the secrets of memory and then applying those secrets to AI. That's a pretty wild idea. But how do we actually go about building this LTM for AI? I mean, what does that even look like?
It's definitely a complex challenge. The paper explores a few pretty interesting strategies for building LTM and AI. They talk about collecting real-world data, generating synthetic data, and even using fancy techniques like vectorization and embedding.
Okay, hold on. Break that down for me. What are vectorization and embedding?
Sure. Think of it this way. Vectorization, it basically transforms data, like text or images, into numbers, like a code that AI can understand. And then embedding, that takes it a step further. It captures the relationship, like the meaning, between different pieces of data.
So it's kind of like translating human experiences into a language that AI can understand and store in its memory.
Exactly. A great example is the work being done in mental health. Researchers have created this massive data set of voice recordings from actual therapy sessions. This raw data, once it's processed and structured, it becomes part of the AI's LTM.
Wow. It's like giving AI a crash course in human emotions and experiences, letting it learn from real conversations and develop a deeper understanding of how we think and feel. That's pretty incredible. But here's the thing. Having a library of memories is one thing, but knowing how to use them, well, that's a whole other challenge. So how does LTM actually fuel AI self-evolution? I mean, how does it go from just storing memories to actually learning and adapting from them?
Now, that's where things get really interesting. The paper, it outlines three main strategies.
Right.
First, you can use LPM as kind of an external knowledge base.
Yeah.
Like imagine a massive library that the AI can tap into as needed.
So kind of like giving the AI a library card. That's pretty cool. But what are the other strategies?
Well, the second one involves directly weaving LTM into the AI model itself. This is done during training. It's like embedding knowledge straight into the AI's core.
So it's like giving it a library card and a personal tutor all in one. That sounds powerful.
Exactly. And then the third strategy involves, a bit of both. It's a hybrid approach, combining those external knowledge bases with embedded LTM. And this could give AI incredible flexibility and efficiency in how it learns and adapts.
This is blowing my mind. We're talking about AI that could learn from its past, adapt to new info, maybe even discover new knowledge on its own. But surely there must be some serious roadblocks to making all of this work. It can't be as simple as flipping a switch and boom, the AI has human-like memory.
You're absolutely right. There are huge challenges to overcome when it comes to using LTM for AI self-evolution. For one, AI systems need to constantly adapt to new data, learn from how users change their behavior. And when you're dealing with limited data, especially for specific individuals, well, it gets tricky to create a comprehensive and reliable LTM.
And let's not forget, human memory itself is still a bit of a mystery. We're still figuring out how our own brains store and retrieve information. Trying to replicate that in AI, that's a huge, huge undertaking.
It certainly is. But, the research also highlights some potential solutions, like developing smarter algorithms and exploring new model architectures that are purpose-built for handling and using LTM. It's all about making sure that LTM works seamlessly within the AI system.
Okay, so we have AI potentially accessing massive libraries of knowledge, learning from real-world experiences, and maybe even challenging Einstein's theories one day. But let's zoom out a bit. We've talked a lot about the potential, but what about real-world implications? How could this tech actually change how we live and work?
The possibilities are vast. It's incredibly exciting. Think about healthcare. Imagine AI assistants powered by LTM and, get this, working together. They can help doctors diagnose diseases more accurately, personalize treatments, maybe even find new cures.
It's like having a team of invisible medical experts working alongside each doctor, analyzing data nonstop, spotting patterns we might miss, offering insights that could be revolutionary.
And it doesn't stop at healthcare. Think about education, right? Personalized AI tutors, adapting to each student's learning style, their pace, their strengths, or even, customer service agents that remember your past interactions, what you like, what you don't like, giving you truly personalized support.
The possibilities seem endless, but as we get deeper into this uncharted territory of AI self-evolution, we can't ignore the big questions, right?
Yeah.
If AI can learn, adapt, maybe even surpass human intelligence, what does that mean for humanity?
That's the million-dollar question. Researchers, philosophers, policymakers, they're all wrestling with this right now. As AI systems get more and more sophisticated, it's crucial we think about the impact on society, the economy, and even what it means to be human.
It feels like we're standing at the edge of a new era, a technological revolution that could totally change our relationship with machines, reshape the world as we know it. But before we get swept away by these big visions of the future, let's step back and consider what the research says about the next steps in AI development. What are the challenges and opportunities that are right around the corner?
That's where the concept of multi-agent collaboration comes in. Imagine a team of specialized AI agents, each with their own unique skills and LTM, working together like a highly skilled team of humans. And that's what we'll dive into after a quick break. Welcome back. Before the break, we were talking about how LTM could power, this idea of multi-agent collaboration in AI. It's pretty fascinating. Imagine a team of AI agents, each one with its own special LTM, all working together to tackle complex problems.
So instead of one giant AI trying to be a master of everything, we're talking about a team of specialists, each one bringing its own knowledge and experiences to the table. That sounds like a recipe for some serious breakthroughs.
Exactly. Think of it like a team of doctors, right? Collaborating on a tough diagnosis. You might have one AI that's a whiz at analyzing medical images, another that's all about patient history, and then another one that's an expert in the latest treatments. Each one contributes, learns from the others, constantly refining its own LTM, getting better and better at what it does.
Okay, yeah, that makes sense. But to really make this multi-agent collaboration work smoothly, these AI agents would need a way to communicate, right? To share their LTM effectively. It's like if you had a team of brilliant minds stuck in separate rooms, unless they can share their insights, what good is it, right?
Absolutely. And that's where this Omne framework comes in. The research paper, it highlights this development framework that's specifically designed for LTM implementation in multi-agent AI systems. Basically, Omne gives you the tools and the infrastructure to create AI systems where multiple agents can, interact, share knowledge, and learn from each other's experiences.
So Omne is like the conductor of this AI orchestra, making sure everyone's in sync and playing the right notes. But how do we know this Omne thing actually works? It sounds pretty theoretical.
Well, the exciting part is Omne's already proven itself. There was this AI competition, pretty prestigious one, and a team using the Omne framework, they built this multi-agent system that totally blew away the competition. It aced tasks that needed complex reasoning, planning, coordination, the whole 9 yards.
Wow, that's impressive. It sounds like Omne is showing us that this vision of multi-agent collaboration, it's not just a futuristic dream, it's a real possibility with real-world applications. But let's zoom out for a second. We've talked a lot about the potential of AI self-evolution, this whole LTM thing, but what about the impact on the world around us? How could this technology actually change how we live, how we work?
Oh, the potential applications are huge. It's mind-blowing. Take healthcare, for example. Imagine a future where AI assistants, powered by LTM, working together like we've been discussing, they could help doctors diagnose diseases way more accurately, personalize treatment plans, even discover new cures.
It's like having a team of invisible medical experts working alongside every doctor, constantly analyzing data, spotting patterns, offering insights that might otherwise be missed. That could totally change the game for healthcare.
And it's not just healthcare. Think about education, personalized AI tutors, adapting to each student, how they learn, their pace, what they're good at, or even customer service agents that remember your past interactions, what you like, what you don't like, truly personalized support.
Yeah, the possibilities, they just keep expanding. But, as we go deeper into this uncharted territory, this world of AI self-evolution, we can't ignore the big, the really big questions, right? If AI can learn, adapt, maybe even become smarter than us, what does that mean for humanity?
That's the question, isn't it? The one that researchers, philosophers, policymakers, they're all grappling with. As AI systems become more and more advanced, it's crucial we consider the impact, on society, the economy, even what it means to be human.
It feels like we're on the verge of something huge, right? A technological revolution that could redefine our whole relationship with machines, maybe even reshape the world as we know it. But before we get swept away by these grand visions of the future, let's take a step back, look at what the research tells us about the next steps in AI development. What are the immediate challenges and opportunities we need to tackle?
One of the biggest areas the research highlights is, it's the need to develop even better methods for building and managing LTM in AI. Think of it like, upgrading the AI's memory from a simple filing cabinet to this massive interconnected library, with smart search capabilities.
So it's not just about stuffing more info into the AI's memory. It's about making that information easy to find, easy to search, relevant to the problem at hand. It's about making sure that memory is actually useful.
Exactly. And another key area is designing new model architectures that are, basically built for LTM. We need AI models that can hold onto knowledge for a long time, seamlessly weave new info into their existing memories, and then pull up relevant knowledge quickly and efficiently when they need it.
So we're talking about designing a brain that's built for lifelong learning, one that's constantly adapting, evolving based on new experiences and information.
That's the idea. And the researchers, they also emphasize this need for better integration of LTM with something called inference time search. This is all about giving AI the ability to actually search their LTM while they're solving a problem, allowing them to adapt to new situations, explore different possibilities, come up with creative solutions.
So instead of just relying on pre-programmed responses, the AI can think on its feet, use its past experiences, reason its way through complex challenges. That's amazing.
Imagine an AI assistant that can help you plan a trip, right? Not just by giving you generic travel recommendations, but by actually remembering your past trips, what you liked, what you didn't like, learning from your feedback and adjusting its suggestions to fit you perfectly.
That's the kind of AI I want. But, beyond these technical advancements, the paper hints at an even bigger vision for the future of AI. They call it a second emergence of intelligence, driven by this multi-agent collaboration and LTM we've been discussing.
It's a powerful idea. It suggests that when you have a diverse group of AI agents, each with its own specialized LTM, all working together flawlessly, they can achieve a level of intelligence that's beyond anything we've seen before, even surpassing the most advanced single AI systems. It's like, the difference between a solo musician and a full symphony orchestra, the power of many working in harmony.
So we're talking about AI systems that can collectively learn, adapt, and solve problems in ways we can barely even grasp. It's mind-blowing. But it also raises some pretty profound questions about the future of us, of humanity, our relationship with these increasingly intelligent machines.
And that's the message the research leaves us with, right? The future of AI, it's not set in stone. It's up to us, to all of us, to shape how these technologies are developed, how they're used, making sure they align with human values, that they contribute to a better world for everyone.
That's a crucial point. We can't just sit back and watch as AI evolves. We need to be active participants, asking the tough questions, making sure these powerful technologies are used for good.
Couldn't agree more. It's a thrilling time to be witnessing these advancements in AI. But it's also a time for, well, for thoughtful reflection, for responsible action. We have a role to play in shaping the future.
This deep dive, it's definitely given me a lot to think about. And I'm sure you, dear listener, are feeling the same way, fascinated by this world of AI, self-evolution, long-term memory, all of it. We've only scratched the surface today, but I encourage you to keep exploring, keep asking questions, stay engaged in this conversation about the future of AI. It's a conversation that affects us all.
And remember, the future, it's not something that just happens to us. It's something we create together.
That's the perfect way to wrap things up. Thanks for joining us on this incredible journey into the world of AI, self-evolution, and long-term memory. Until next time, keep on learning, keep on exploring, and keep those questions coming.
So where do we go from here? What's next in this whole world of AI self-evolution?
That's a great question. We've laid out the groundwork, explored the possibilities, but what are the concrete steps, the research avenues that we need to pursue?
Well, the paper actually does a great job of outlining some key areas for future exploration. And one of the most exciting ones is, well, it's this idea of developing even better ways to construct and manage LTM in AI.
Okay, so not just about cramming more data into AI's memory, right? It's got to be more than that.
Right. It's about, think of it like upgrading the AI's memory storage, right? Going from a simple filing cabinet to this huge interconnected library, with intelligent search capabilities.
So it's about accessibility, searchability, making sure the info is relevant, that the memory is actually useful.
Exactly. It's about making that LTM work for the AI, not just sit there. And another crucial area is, actually designing new model architectures, ones that are specifically optimized for LTM.
Wait, so like building AI brains that are designed for lifelong learning.
Exactly. We need AI models that can hold on to knowledge for extended periods, seamlessly integrate new info into their existing memories, and then, just as importantly, retrieve relevant knowledge quickly and efficiently when they need it.
It's like designing a brain that's built for constant adaptation, always evolving based on new experiences and information.
That's a great way to put it. And then there's this other fascinating area the researchers talk about. It's called inference time search. Basically, it's about giving AI systems the ability to actually search their LTM during the problem-solving process.
So the AI isn't just spitting out pre-programmed answers, right? It can actually think on its feet, use its past experiences, reason its way through a problem.
Exactly. It opens up all these possibilities for AI to adapt to new situations, explore different options, come up with creative solutions. It's like it's giving them the tools to really think.
Now, that's what I call intelligent. It's like, imagine an AI assistant that helps you plan a trip. But it's not just giving you generic recommendations. It actually remembers your past tricks, what you liked, what you didn't like. It learns from your feedback, and its suggestions actually get better over time.
That's the kind of AI we're all hoping for, right? But even beyond all these amazing technical advances, the paper actually points towards an even grander vision for the future of AI. They call it a second emergence of intelligence. And it's driven by this idea of multi-agent collaboration and LTM that we've been talking about.
Okay, so remind me, what is this second emergence of intelligence?
Sure. So basically, it suggests that when you have a bunch of different AI agents, each with their own specialized LTM, and they're all working together flawlessly, well, they can actually achieve a level of intelligence that's greater than the sum of their parts. It's like, think of a solo musician versus a full symphony orchestra, right? The power of many working in perfect harmony.
So we're talking about AI systems that could collectively learn, adapt, and solve problems in ways we can barely even imagine. It's mind-blowing, but it makes you think about the big picture, right? What does this mean for humanity? Our relationship with these increasingly intelligent machines. It's a little daunting, to be honest.
It is. And the paper, it really drives this point home. The future of AI, it's not set in stone. It's not predetermined. It's actually up to us, to all of us, to decide how these technologies are developed, how they're used. We have to make sure they align with human values, that they contribute to making the world a better place.
That's such a crucial point. We can't just sit back and passively watch as AI evolves, right?
Yeah.
We need to be involved, asking the tough questions, making sure these powerful technologies are used for good.
Absolutely. It's an incredibly exciting time to be witnessing these breakthroughs in AI, but it's also a time for reflection, for responsible action. We all have a role to play in shaping this future.
This deep dive, it's really been eye-opening, and I'm sure our listeners are feeling the same way, fascinated by all this world of AI, self-evolution, and long-term memory. We've only just scratched the surface today, but I really encourage everyone to keep digging deeper, keep asking those tough questions, and stay engaged in this conversation about the future of AI, because it's a conversation that affects us all.
And remember, the future, it's not something that just happens to us. It's something we create together.
That's a perfect note to end on. Thanks for joining us for this deep dive into the world of AI, self-evolution, and long-term memory. Keep those brains buzzing, and we'll catch you next time.